So Bell's solution was to take two pairs and twist them around each other, which is very smart, okay? But, like I said, it's got problems, especially as you go over longer distances. This is what Ricky was saying, okay? That little bit of interference that can come in over a long distance, it's really going to add up, okay? So people designed this stuff. This is called coaxial cable. Coaxial cable is where, once upon a time, you used to have dial-up internet, or you used to have cable internet. Now you're like, hold on. Dial-up internet, it still comes through cables, right? Well, the cable of cable internet is coaxial cable. Okay, so let me try and explain this. Okay, here's a diagram. Well, sorry, it's not a diagram, it's a photo. Okay, and you can see it's quite on a small scale. Okay, and you've got these 4 different elements. Okay, so let me go through each one. What you've got in the middle is just a single copper wire. A single copper wire. Okay. So if you like, I'm going to cut it across ways, and I'm going to look at it side on. So this is a cross section. Okay. So I've got this, and yeah. Okay, I'll do this. Okay, what are we looking at? Now, just before I give you any more details, apart from the fact that you've got this single copper wire in here, I should say it's single because that's important. Why is this called coaxial cable? What do you think is the word that's underneath? Sorry, start again. What does co mean? When you put co on the front of a word, what does that mean? Like coordinates, or coordination, or together, right? So things that are doing the same thing, right? When you've got co in front of axial, what do you think is the axial is an adjective? What do you think is the noun underneath axial? Axis, right? So the idea here is all of these different layers. There's 4, okay? They all share the same axis of symmetry, okay? As opposed to this twisted pair. These have opposite axes, right? But coaxial cable, everything's on the one axis, so that's why it's called coaxial. Okay. So what are the things that are sharing an axis? Well, number 1, you got this copper wire. Number 2, you've got this insulator in here. It's usually plastic. Okay. Then what you've got is actually, and if you can probably see it, make it out on the photo. What's this part here? This is metal. Why would they put metal there? It's not to transmit signals. What's that metal for? Yeah. Good. Again, we're trying to cancel out things coming from the outside. Okay. So they call that part a metal sheath. Okay. So again, it's trying to cancel out the electromagnetic interference in the same way that a second cable would, but it does a much better job. Okay. Lastly, you just have a wrapper for this so that you can hold it with your hand. And you're not going to be holding the metal, okay? So this stuff is a lot more expensive, okay? Because for every coaxial cable, you've just got one signal, whereas for twisted pair, you've got double, right? And also all these extra layers and that kind of thing, particularly this metal sheath, they're quite expensive to produce, okay? So coaxial cable is more costly, but it can go much further. And you can send more data through it more reliably. That's why cable internet is so much faster than dial-up. Okay? Because you can send through things here and know that over a long distance there's going to be less interference. Okay?